Welcome everyone. In this video, I'm going to go through 5 A-level chemistry multiple choice questions. The questions are from the 2017 AQA Paper 3 and cover reactions of alcohols, organic mechanisms, pH curves, equilibrium constants in terms of partial pressure, Kp, and isomers. Let's get started. Here's the first question. An equilibrium mixture is prepared in a container of fixed volume. CO gas and Cl2 gas are in equilibrium with CO-Cl2 gas. The enthalpy change delta H is equal to minus 108 kilojoules per mole. The temperature of this mixture is decreased and the mixture is allowed to reach a new equilibrium. Which is greater for the new equilibrium than for the original equilibrium? And we're given a choice of A, the mole fraction of carbon monoxide, B, the partial pressure of chlorine, C, the total pressure of the mixture, or D, the value of the equilibrium constant Kp. Let's consider some key facts. Kp is only constant at constant temperature. The forward reaction is exothermic. The equilibrium will shift to the right when temperature is decreased. This final point is linked to Le Chatelier's principle, and equilibrium will shift to opposed change applied. Because the equilibrium will shift to the right when temperature is decreased, the mole fraction of carbon monoxide will decrease. Therefore, option A is incorrect. Because the equilibrium shifts to the right, the mole fraction of chlorine also decreases. Partial pressure is proportional to the mole fraction, so the partial pressure of chlorine will decrease. Therefore, option B is also incorrect. There are 2 moles of gas on the left-hand side of the equilibrium and 1 mole of gas on the right-hand side of the equilibrium. Because the equilibrium shifts to the right, the number of particles in the same volume will decrease. Therefore, the total pressure of the mixture will also decrease. Option C is incorrect. The Kp expression is shown here. It is equal to the partial pressure of CoCl2 divided by the partial pressure of CO multiplied by the partial pressure of Cl2. Because the equilibrium shifts to the right, the value of the numerator increases and the value of the denominator decreases, so Kp increases. Option D is the correct response. Here's the next question. In concentrated alkali, propanone reacts with hydroxide ions to form an equilibrium mixture as shown. Which curly arrow does not appear in the mechanism of this reaction? Curly arrows show the movements of a pair of electrons, and this is always associated with bonds breaking and or bonds forming. Option A shows a CH bond breaking and a CC double bond forming. Option B shows a C double bond O breaking to leave a C single bond O and a CC double bond forming. Option C shows an OH bond forming from the hydroxide ion. And option D shows a C double bond O breaking to leave a C single bond O with a lone pair of electrons left on the oxygen atom with a negative charge. I've shown the full mechanism here with the arrows labelled up to correspond to the options in the question. Option B is the correct answer. This step does not appear in the mechanism. Next up, we have a question on a pH curve. The diagram shows a pH curve produced by adding a strong alkali to a weak acid. Which point on the curve represents a solution that can act as a buffer? Buffers resist changes to pH when acid or alkali are added. We can see that at point B, if a small volume of alkali is added or removed, the pH doesn't change very much. The correct answer is option B. Reactions of alcohols next. Which alcohol could not be produced by the reduction of an aldehyde or a ketone? Primary alcohols can be reduced to aldehydes. Secondary alcohols can be reduced to ketones. Tertiary alcohols are not produced by the reduction of aldehydes or ketones. Sometimes it is easier to classify the alcohols as primary, secondary or tertiary if we draw them out, like I've done here. In each case, look at the carbon that is attached to the OH group. In option A, the COH carbon is also attached to one alkyl group. It is a primary alcohol. In option B, the COH carbon is attached to 3 alkyl groups. It is a tertiary alcohol. In option B, the COH carbon is attached to 2 alkyl groups. It is a secondary alcohol, and the same can be said for option D. So the correct answer is option B, 2-methyl-butan-2-ol. Here's the next question. Which compound does not show stereoisomerism? Stereoisomers have the same structural formula but a different arrangement of atoms in space. Optical isomerism and EZ isomerism are types of stereoisomerism. If we take each option in turn and draw the structure out from the name, we can see that in the case of option A, it will show EZ isomerism. This occurs in alkenes if each carbon in the carbon-carbon double bond is attached to two different atoms or groups. If we look at option B, this will exhibit optical isomerism. Optical isomers are non-superimposable mirror images. Optical isomerism occurs if a carbon atom in a molecule is attached to four different atoms or groups. Option C will also show EZ isomerism. The structures of the two isomers are shown here. Post in the comments if you can identify if the E or Z isomer is highlighted. And finally, option D. It is not an alkene, so it is not possible for option D to show EZ isomerism. None of the carbon atoms in this structure are attached to four different atoms or groups. That is to say, there is no asymmetric carbon, so the molecule is not chiral. The correct answer is option D for this question. If that helped, watch this next video and subscribe for more chemistry explained. Also, check out the FlipCam website and register for your free account. You'll get access to over 50 chemistry quizzes with instant feedback. Details are in the description. Any questions or topic requests, just post in the comments. Take care and good luck with your studies.